In physics, equilibrium is defined as a state in which opposing forces or influences are balanced. For example, right here, I have a physics textbook. When I set the textbook down on this table, it is in equilibrium because the force exerted by the textbook is canceled out by the force exerted by the table. But what if, instead of equilibrium between two objects, we had gravitational equilibrium between two planets? Now I know what you're thinking. What is she talking about? Well, it's a known principle that anything with mass must also have gravity. If two masses are large enough, there will be points at which their gravity comes to equilibrium, so much so that an object can exist in orbit at those points. These points are called Lagrange points. Lagrange points are named for 18th century mathematician and astronomer Joseph Louis Lagrange, who is known for his works on number theory and classical mechanics, among other things. Let's dive a little deeper into Lagrange points, but first we're going to need some pretty large masses. Perfect. Now, there's one more condition to go over before we can look at where these points are. The mass ratio between the larger mass and the smaller mass has to be at least 24.96. There are a lot of different bodies in our solar system that obey this condition, most notably the Sun and the Earth. Now, where do we find Lagrange points? Right here, we have the Earth and the Sun. Let's pretend that they're to scale. Earlier, I said that there are 5 Lagrange points between two masses. There are 2 stable and 3 unstable, which I'll explain a little bit later. The 3 unstable points all lie in a line that passes through both bodies. L1 lies between the Sun and the Earth, L2 on the side of the Earth, and L3 on the side of the Sun. The other two, L4 and L5, lie at the vertex of an equilateral triangle with the Sun and the Earth at the other vertices. Let's talk about what being a stable or an unstable Lagrange point actually means. It's exactly what it sounds like. Stable Lagrange points are able to hold objects in a constant, stable orbit. There are thousands of asteroids located at stable Lagrange points all across the solar system. They're commonly referred to as Trojans. Unstable Lagrange points, on the other hand, cannot hold objects in a constant orbit without frequent modifications to their position. Luckily enough, that's not as much of an issue for spacecraft. In fact, L1 is the current home of the Solar and Heliospheric Observatory satellite, and L2 holds the James Webb Space Telescope. There is no current use for L3 due to its location behind the Sun. Although humans have only utilized the Lagrange points between the Earth and the Sun, there might come a day when we are using the points located all across the solar system and beyond. Thank you so much for watching, and I hope you learned something.